let's talk about intercept form of quadratics. Intercept form looks something like this. A is your leading coefficient. That's going to tell you if you have any sort of vertical reflection, vertical stretch, or vertical compression. But the intercepts are your P and Q values. So these two are your x-intercepts. And the reason why is because if I were to put in that p-value for x or my q-value for x, I would end up getting 0 for y. So let's go ahead and take a look at that. Let's say my x is p. Then my y value equals a times p minus p times p minus q. The only piece I can simplify here is this middle one, p minus p, which is 0. So y is a times 0 times p minus q. And I really don't care what a is or what p minus q is because we're multiplying by 0. So I would end up with a y value of 0. So I have the point where x is p and y is 0, meaning that this is an x-intercept of my graph. And the same thing's going to happen if I plug in a q. If x equals q, we have y equals a times q minus p times q minus q. And again, the only piece I can simplify here is that third factor of q minus q. A times q minus p, and then q minus q is 0. So I don't care what a is, I don't care what q minus p is, we're multiplying by 0, which means that y is going to be 0, and my second intercept is q for x and 0 for y. Let's go ahead and do an example that has some numbers in it. It should all come together. So in this example, I'll compare it to y equals a times x minus p x minus q. And I'm trying to find my p value and my q value. The very first thing I want to do to graph from intercept form is to find the p value and the q value. So comparing it, notice that I have a positive 3 and I'm comparing that to a negative p. You could go ahead and write the equation 3 equals negative p and then divide out that negative 1, giving you negative 3 is p. Or we can just say it's the opposite of that number with x. So looking at my second factor, if I were to compare these two, I'm looking at the opposite of the number with x. So instead of writing my equation, I'll go ahead and just say that q is the opposite of that minus 1, which is positive 1. And if you don't like that, then we can go ahead and say negative 1 is equal to negative q. And I can write the equation here, negative 1 equals negative q. Divide by negative 1 on both sides, and guess what? We get q is 1. So here are my two x-intercepts. We can write them as ordered pairs if we want, or you can just keep them as individual values. But I'm going to go ahead and take these 2 points and put them on my graph. So let me clean up and draw myself a coordinate plane. Now that I've got my coordinate plane drawn out, let me start by plotting my two x-intercepts. My first is negative 3, 0 and positive 1, 0. So I know my graph goes through these 2 points, but I'm not sure what it looks like. So maybe it looks something like this. Maybe it faces up and it's super tall and skinny, and it looks something like that. So we need a little bit more information to be able to sketch the final parabola for our equation. What I know about parabolas is that they are symmetric, which means my vertex has to be exactly in the middle of these two intercepts. So I could go through and just kind of figure it out from the graph. I've got negative 3 and positive 1. If I go 2 this way and 2 this way, I meet in the middle at negative 1. So my axis of symmetry has to be at negative 1, or that's the middle of my graph at negative 1. If you wanted to find it more algebraically, I'm going to find the x value of my vertex by noting that it is in the middle of my graph. So it has to be in the middle of negative 3 and 1. So to find the middle, I take those two values, negative 3 and 1, I add them, and I divide by 2. So I get negative 2 over 2, which is an x value of negative 1. So sure enough, my axis of symmetry is a vertical line through x is negative 1. Now I know because parabolas are symmetric that my vertex has to lie on this line. So let me take that -1 for x, plug it into my equation, and figure out what the y value would have to be. And then I'll have the coordinates of my vertex. I plug in a -1 for x in both factors and simplify. This tells me the y value of my vertex is 4. So my vertex has the coordinate -1 for x, +4 for y. So that would be right about here. Now that's enough information for me to sketch my graph. I connect all 3 points the best that I can. And this is the graph of my quadratic. And that's it. Thanks for watching, and I'll see you next time. Bye.